Welcome to Miyconst Hardware. Right now you can see the project I'm working on, and this one is a NAS or network attached storage for my personal use. As you can see, I have 3D printed this chassis, and over here at the bottom you can install 4 hard drives, and on the other side you can add 2.5-inch SSD drives if needed be. This video though is going to be about the hard or about the computer that's going to control this NAS device, and this is Odroid-H4 SBC or single board computer. To start, let's go through the full technical specification of this Odroid-H Plus SBC. Here we have Intel N97 CPU. This is not an Intel Core CPU, it's just Intel N97, and here we have only 4 E-cores or so-called Intel efficient cores. The CPU clock frequency goes up to 3.6 GHz, we have only 6 MB of cache, and the maximum TDP is about 12 watts. For the memory, we have single channel of DDR4 or DDR5, depending on what is installed on your motherboard. With Odroid-H4, we have single slot of DDR5, which is located at the back side of the motherboard, and RAM overclocking is not supported. Intel claims that the maximum memory is 16 GB, but I have a 32 GB stick and it works just fine. Also on the Odroid website you can see that they have tested 48 GB sticks and it also works. Additionally, Intel N97 has built-in iGPU, which is UHD graphics with 24 execution units. This iGPU supports up to 3 4K monitors at 60 Hz, which is a very big disappointment for me because I have a 4K 120 Hz TV and I cannot use Odroid-H4 with my TV. 60 Hz is not enough for 120 Hz TV. I am not interested in the iGPU performance, but if you are, you can see A-64 GPGPU results on your screen. Additionally, on the board we can see an eMMC connector where you can plug in storage modules up to 256 GB. For myself, I purchased a 32 GB module, and this module is not detected by Crystal Disk Info. Still, in the task manager we can see that it is a Kingston PJ3032. Online I could not find any specific information about this module. Still, we're getting somewhere between 310 and 142 MB per second read and write speed. How long this module is going to last, I have no idea, so if you decide to use one, well, the risk is yours. For the network, we have two 2.5 Gigabit Ethernet Intel i226V, which is very nice. Additionally, we have an S-Media ASM1064 SATA controller with 4 SATA ports. We also have a Realtek ALC897 audio codec, and on the back side we have an M.2 slot, which is PCI Express 3.0 X4, and that is also awesome. Comparing different tiers of Odroid-H4, we have H4 with no SATA ports, H4 Plus, the one I have, and H4 Ultra, which uses Core i3 and 305. This Core i3 has 15 watts TDP, maximum 3.8 GHz speed, and 8 cores instead of 4 cores. The pricing goes like this. The base Odroid-H4 costs $99 USD. The H4 Plus, the one I have with the SATA ports, costs $139 USD, and H4 Ultra costs $220 USD. In my opinion, the Ultra version is just overpriced. The H4 Plus is perfect if you need the SATA ports, and the base H4 is also perfect if you do not need the SATA ports. For all of the 3 versions you would also need DDR5 memory, and the cheapest 8 GB stick I could find would cost about 22 USD. For some perspective, let's check Raspberry Pi pricing. The Pi 5 with 4 GB costs 60 USD and with 8 GB costs 80 USD. But if you would want to use the pathetic M.2 connector from Raspberry Pi, then you also need to buy a Pi hat. That's additional 14 USD. As you can see, lately the ARM-based SBCs are going up in the price and x86 SBCs are going down in the price. And right now the 8 GB Raspberry Pi cost about not as much as Odroid-H4. In my opinion, in this case, Odroid-H4 is a clear winner because it has a way much better connectivity and it also does not have all the possible software issues with the ARM architecture. Of course, it would only work if you can physically fit larger H4 instead of the smaller Raspberry Pi. Now, to get this thing working, you obviously need a power supply. Odroid-H4 uses external power supply that connects from the I/O side of the motherboard. Here we have a few different options. The first one and the simplest one is to just buy official power supply from the hard kernel website. They have 15 and 19 volts options for a reasonable price. I am not known to pick the easiest route, so I decided to explore other options. And according to the official specification, Odroid-H4 supports voltage input from 15 to 20. But it turns out that it also works with the standard ATX power supply and 12 volts. So on AliExpress I bought this CPU power extender from 8-pin CPU power to 8-pin CPU power, and additionally bought this kind of power jack that goes into Odroid SBC. Then I just cut off a couple of wires, injected them into this jack, and you can plug it into your SBC, and this goes to the ATX power supply. Obviously, if the power supply is not connected to the motherboard, it will not power on, so additionally you would need this kind of adapter. This goes to a 24-pin power connector from the power supply, and here you get a button to power it off or on, depending on what you want. It is a suboptimal solution because you will get one extra power button, but it works, and it works especially well if you need lots of SATA devices, because on this SBC we have only 4 SATA ports over here, actually SATA ports over here, and these are SATA power. It is also important to mention that these SATA power ports are working only if you supply at least 19 volts into the SBC from your power supply. So if you're using this kind of adapter with a 12 volts input, or if you're using 15 volts power supply from hard kernel, then the SATA power from the motherboard, these ones are not going to work. Probably like many of you, I have several different power bricks lying around, and the first one that I found compatible is this power brick from an old Intel NUC. The power supply gives the required 19 volts, but the wattage is just 19 watts. The power connector is also compatible with the Odroid-H4, so it is a plug and play. 90 watts is probably enough, but the official 90-volt adapter from hard kernel gives you more, so I decided to explore other options. So I decided to use this old Lenovo power brick for 135 watts and 20 volts input. In my testing, this turns out to be the most efficient power supply for hard kernel Odroid-H4, but it uses this kind of squarish or rectangular power jack. So to be able to use it with Odroid-H4, you would need this kind of a connector. So this goes in here, just like this, and then this part obviously goes into the Odroid-H4, and you can see that right now I have one of these installed. It goes over here, and then the other side goes to the back side, where I plan to hide all the cables and this power brick itself. Once you get your power supply sorted out, the next big thing will be the drivers. And here I have some bad news. Windows does not yet detect this platform and does not automatically install required drivers. This also includes the network adapters. Without manual driver installation, you will be without internet and without Ethernet. I did not find any official pages for Odroid-H4 where I could download drivers, but I found that ASRock has a device called NUC Box N97. It is based on the same platform and the drivers are fully compatible. Of course, the link will be in the video description. My apologies for this injection, but I forgot to mention that the ASRock NUC drivers are applicable for the platform and chipset itself. For the Intel Ethernet adapters, you need to download Intel drivers and install them separately. With the drivers installed, I can do some performance testing. Intel N97 has 2 operational modes, with and without power consumption restrictions. By default, the CPU is limited to somewhere 10 watts of power consumption, and this is the first configuration I have tested. Since the Odroid-H4 comes without a fan, I decided to test it without the fan in the stock configuration. With the Cinebench R23 10-minute CPU stress test, CPU temperature goes up to 88 degrees Celsius. It is really not ideal, but it is still borderline operational. So if you are not living in a hot climate and you are not torturing your CPU with 100% utilization all the time, I could argue that Odroid-H4 in the stock configuration can be used without a fan. In this configuration, CPU Z scores are 310 and 1030 points. For some sort of a perspective, let's take scores of i7-2600K. It scores 345 and 1686 points. In Cinebench R23, this little N97 scores 738 and 2038 points. In Geekbench 6, we have 1185 and 2500 points. For some perspective, let's take a look at the Raspberry Pi without overclocking. It scores somewhere around 800 and 1500 points. Lastly, the memory performance. Even though we have only single stick of DDR5 4800 CL40, the performance is not that bad. The results in 8064 are 27, 33 and 32 GB per second for a read-write and copy. The memory latency of just 44–45 nanoseconds is a very big surprise to me. Usually DDR5 and Intel E cores are not known for good memory latency, but in this case the latency is really nice. Some power consumption figures. The stock configuration I have only tested with the Intel NUC power supply. In Cinebench R23 we have 21 and 22 watts with a single or all 4 CPU cores under load. And this is because the CPU is power restricted. With just one CPU core the frequency goes higher, with all CPU cores the frequency drops. During idling the system consumes about 11 watts, and during sleep the system consumes less than a single watt of electricity. Overall, these test results are pretty good for what Intel N97 is, but let's remove the power consumption limit and see what we get. To remove the limit, you need to go into the BIOS, then Power and Performance, then CPU Power Management, then Power Limit 4 set to 0. 0 means no limit. Save it, reboot, and your CPU will work with maximum power consumption. In this case, Cinebench R23 test failed without a fan. CPU temperature goes up to 95 degrees Celsius and the CPU starts to throttle. I think this kind of configuration is not only throttling the CPU, but it is also dangerous for your computer's lifespan. That's why the unlimited power configuration was tested with an extra fan installed. In this case, the scores are CPU Z 360, 1273 points. It is very close to i7-2600K that scores 345, 1686 points. In Cinebench R23 we have 956, 2871 points. In Geekbench 6, the score increases to 1294 and 3315 points, which is significantly better than overclocked Raspberry Pi 5. That one scores 900, 2000 points. Without power limitation, the memory performance is also better. Here we have 32, 33 and 32 GB per second for a read-write and copy. The memory latency is also slightly better, 43–44 nanoseconds. Power consumption testing Intel NUC power supply are increasing a bit. With a single core under Cinebench R23, the system consumes 24 watts. With all cores, the power consumption is about 30 watts. Idle power consumption is about the same, 11 watts, and the sleep power consumption doesn't change, it is less than a single watt of electricity. With the Lenovo power supply, the power consumption with the Cinebench R23 test is about half a watt less, but with the ATX Corsair RM850 power supply, the power consumption figures are not as good. Cinebench R23 test consumes 26–31 watts, but what's really annoying with this power supply is that the sleep and idle power consumption jumps up to 4.5 and 14 watts. Especially the sleep power consumption is annoying because the Odroid-H4 is not directly connected to the ATX power supply and it does not have a feature to power off the power supply during the sleep mode. I have also tested boot time, so from a complete off to Windows desktop, Odroid-H4 consumes about 20 seconds, which is very decent. From sleep to Windows desktop, it takes about 5 to 6 seconds, and a reboot from Windows desktop to Windows desktop takes about 30 seconds. Odroid-H4 also has a working smart fan function, but unfortunately we have only one 4-pin PWM header. In the BIOS there is a setting to switch between PWM and RPM options, and I would guess that RPM means it is for the 3-pin voltage regulated fans. Unfortunately, it doesn't seem to be so. I tested multiple 3-pin fans and in all cases the 3-pin fans are working at 100% speed. The speed is only adjusted when I connect a 4-pin PWM fan. Also, HW monitor does not detect fan speed and does not report it, so you are relying on the BIOS readings. Power and reset buttons. On board we have power button here and reset button here, but obviously you don't want to reach out for these once your Odroid-H4 is enclosed. So here we have your buttons and LEDs, I think, but I was not able to find official schematics for the Odroid-H4. Instead I found one for Odroid-H3 and they do seem to be identical. So here I connected this power button to the pins 17, 19 and it works just fine. The rest of the pins I did not test though. Here you can also see that unlike Chinese AliExpress offers, Odroid-H4 comes with this CMOS or BIOS battery, so you don't need to buy one. Another important thing to cover is this SATA power cord. The easiest solution is to buy it from the hard kernel website together with your Odroid-H4 board, but again, I'm not known to pick the easiest route, so I not only bought these official cables, I also bought a whole pile of them from AliExpress with the hope that at least one of them will fit. And I kind of found one that fits, so let me connect it and show you what I mean. It perfectly fits in. This one is the official one, this one is the one I bought from AliExpress. And if you're careful enough, you will see that the red and yellow wires are flipped, and that means that we need to manually replace these wires to use with Odroid HPC motherboard, because otherwise you will fry, or most likely will fry, your SATA devices. The yellow cable is 12 volts and the red cable is 3 volts, as far as I remember. Additionally, I have also tested this M.2 to 6 SATA ports adapter from AliExpress. It works just fine, it consumes only 2 PCI Express lanes, so it's a bit of a pity that we cannot use all 4 PCI Express lanes, but it works just fine with no issues. So all the devices I connected here were detected by the system, worked with no issues, and it is also possible to install system on a device connected here and boot from a device connected here. So if you need more SATA ports, you have such an option, but obviously you would have to use an ATX power supply with more SATA power connectors. Hard kernel also has an official Odroid Mini-ITX conversion kit that seems to be nice, but when I bought my H4 it was out of stock, and honestly I kinda dislike how the power plug sticks out from the motherboard. H4 is smaller than Mini-ITX, so it is possible to put the motherboard inside the chassis and hide this ugly sticking out power plug that routes back into the chassis to get connected to an ATX power supply. Still, if you like it, it seems to be decent and the pricing is also okay. To conclude this video, I would like to say that Hard Kernel is a Korean company and not a Chinese one. Working with Odroid-H4 is a pleasure, and I can feel the quality difference between the Chinese AliExpress offers and this Odroid-H4 board. The website is also pleasant to use and it has almost everything you would want to. Not everything, but almost everything. Definitely I can recommend Odroid-H4 if you need one, or if you don't need one but you can afford a toy, give it a try and see what you can get it to. With this, I have to say thanks for watching, thanks for listening, I hope to see you in the next one, and I hope this video was helpful. Bye for now.